In this video, I'll tell you how to draw a perfect cube, and it's all in my book, Ellen's Guide to Perspective, where the Kindle is only $5. This is the setup for an eye-level viewpoint when we're looking straight ahead, and all the action happens on this picture plane. And this is the front view of the picture plane and the side view of the picture plane right here. And it's a transparent vertical plane perpendicular to the ground. You can see that it's perpendicular here. The eye, or the station point, is above the ground, so this distance is the height of the viewer standing on the ground. The cone of vision is from visual rays coming from objects in the environment coming to the eye of the viewer. This cone of vision is usually about 60 degrees. It marks the field of vision on the picture plane here, and over here it's a true circle. Beyond the 60-degree cone of vision, our view is blurry, but in perspective, the shapes become distorted. The line of sight goes from the eye to the center of vision on the picture plane. The ground line here is the meeting of the picture plane and the ground plane, and that's where we do our measuring. So the ground line over here is right here. So let's add to the scheme these orange parallel lines that go to infinity, and imagine them continuing on all the way up to here, where they would meet the line of sight and eventually the center of vision somewhere over here. So if we look at the picture plane in a two-dimensional form, we see, instead of these parallel orange lines, we see these lines converging toward the center of vision. Now, the beauty of this two-dimensional form is that we can measure things. So anything on the picture plane has its true length. So for example, this bar here is actually 1 unit long. The one here is 1 unit in perspective. And it's bigger because it's in front of the picture plane. But since they're both on these same converging lines, they're the same size in perspective. Similarly, this bar is actually 2 units long because it's on the picture plane. And the one behind it here is smaller, so it's 2 units in perspective. How long are the traces on the picture plane? Well, we can use this simple ratio. So let's look at the blue pole. The distance from the eye to the picture plane, that's 1x. The distance of the eye to the blue pole, well, that's 2x. Okay, so that's 1 out of 2. The length of the vertical blue pole, let's call that 4 units. Therefore, the length of the blue line on the picture plane, in other words, the trace, must be 2 units. Here I set up 2 objects on one side of the picture plane and the eye on the other side. And what we need to do is draw lines from the top and bottom of each one of these bars to the eye, and then find out where it intersects the picture plane. And when you do that, you'll find this, and the distance x over the distance y, that ratio, is equal to the size of this trace A over the size of trace B. So they're proportional. We've talked a lot about lines going to vanishing points, but planes can also go to vanishing lines. So here are some vertical planes that are parallel to each other, and they converge toward this vanishing line in the middle. Similarly, these horizontal planes converge toward this vanishing line in the middle. I want to show you how to draw true squares in one-point perspective. So we have to establish the eye below the center of vision. And this line, whatever length it is equal to the length of this, the center of vision to D45, which is the diagonal vanishing point for the 45-degree angle that splits this 90-degree angle at the eye into 2 45-degree angles. Now, the beauty of the D45 is that any diagonal that goes to this D45 must be a square because only squares are divided into two 45-degree angles. So we start with the horizontal part of the square, and the sides converge toward the center of vision. And where this line to D45 cuts across the line going to the center of vision would define the back part of this square. And then we know that this side of the square is equal to this side. Now, you can think of the eye as coming out of the page so that it is superimposed on the center of vision. I can't, of course, draw that. And then we're looking down at these squares below us. To draw the cube in one-point perspective, we start with this square, and its diagonal goes to this vanishing point over here, and this diagonal goes to this vanishing point. Then, using a circle or a compass or just measuring, we want line 1 to be equal to line 2. So they could be both radii of the same circle, for example. And once we have line 2, then we draw lines converging toward the center of vision. We have a horizontal front, and then we know that this diagonal goes to this diagonal vanishing point, and we can finish the cube. Now let's go to two-point perspective and draw two boxes. This first blue box has a vanishing point over here and another one over here, and you can see that the lines make a 90-degree angle at the eye. Now these are vanishing points. These are not the diagonal vanishing points I was talking about before. Now the red box over here, we just draw new lines to the same eye that form a 90-degree angle at the eye, and then we get the right and left vanishing points for the red box over here. Now, draw the cone of vision 60 degrees and bring it to the to eye level so we can draw this field of vision or cone of vision to make sure that both boxes are within our cone of vision. In this case, I drew 4 boxes in two-point perspective. So you can see, for example, the blue box has these 2 vanishing points, and the white box has these 2 vanishing points. And the question is, where is the eye and where is the center of vision? So you draw circles to encompass the vanishing points for each box. And when you do so, you find that there's only one point here where the green box, the magenta box, and the white box, their circles meet, but the blue box does not meet there. So this is the eye for the 3 boxes, and the center of vision would be directly above on eye level. You can use various angles at the eye, although the lines have to add up to 90 degrees. So, for example, a 60-degree angle and a 30-degree angle will add up to 90 degrees, and a 75-degree angle and a 15-degree angle will add up to 90 degrees. But you can see that they bunch up here, and then they spread out over here. I want to show you how to draw this square in two-point perspective. So this angle is almost 90 degrees. Let's just call it 90 degrees. So this would be the eye. And this line goes to vanishing point 1, and this line goes to vanishing point 2. So that's a square in two-point perspective. Now, we need to find these sides so that they're equal to these sides. And how do we do that? Well, down here, you see this distance is equal to this distance. And this first distance accounts for how long C is going to be. And this distance accounts for how long D is going to be. And since these two are equal on the measuring line, that means C and D must also be equal. Now, A is on the same converging lines as D, so A and D must be equal. And B is on the same converging lines as C, so B and C must be equal. In other words, all the sides are equal, so it's a square. Now, interestingly, the diagonal of this square is horizontal, and the other diagonal is vertical, going to the center of vision. Now, you could further divide this square up by using units on the measuring line that are equal. So from 1 to 2, that accounts for this little distance here, and this distance from the eye to 1 accounts for this little distance here. And since this and this are equal, it means that I drew a little square right here. And that's true of all these other little squares. They're true squares in perspective. So remember my book on Amazon, Ellen's Guide to Perspective, and please remember to subscribe.